Welcome back, students. In our last video, 7.1, we learned how to solve systems of equations using graphing. Now what we're going to do is solve systems of equations again, but we're going to use something called substitution. So our objectives are that you'll be able to solve systems of equations using substitution, and you'll be able to define what the substitution method is. I want to start this lesson out by reviewing how to solve a system of equations by graphing. So what we're going to do is we're going to graph both these lines and see where they meet, and that will be the solution to both equations. Alright, so I went ahead and I graphed the first equation, y equals 3x, and I used a red line to represent that. So it's right here on the graph. Here's my blue line, and I extended the red line to keep that pattern going so that they would intersect. So my blue line touched the red line right here, and it is right at an intersection. So let's find that point. These two lines intersect at -1, -3, right here. And remember what that means. If I take a -1 and I put it in, substitute it in for the value of x, I will get a -3. -1 multiplied to 3 is -3. And it works in this equation too. -1 right here minus 2 is -3. Okay, so I proved that it works by graphing. So I want you to remember that the answer is -1, -3. Now watch the next slide. Okay, so we know the answer is -1, -3. I'm going to teach you another way of solving a systems of equations by not graphing, by using something called substitution. The first step is to solve an equation for one variable. Okay, so do that in at least one of your equations has to have one variable isolated. The second step is that you substitute the resulting expression into the other equation, and I will show you what that means. It makes more sense if you watch. And the third step, solve the equation to get the value of the variable. So basically you'll solve the equation. Once you know what x equals or what y equals, then you go back and substitute that in to one of the original equations and solve for the other variable. So these steps are great. I think it's easier to just watch me show you how to do this. In our first example here, we have y equals 3x, and we also have y equals x minus 2. Both equations have y isolated by itself. So when it's like this, it's pretty easy, because here's what I'm going to do. I know that y is equal to y because it's the same variable. So I'm going to say y equals y. Next, what I'm going to do is say, well, if y equals 3x, what I can do, we'll call this the blue y, what I can do is take 3x and substitute it for this y, because I know that this y equals 3x. Next, I can go back and say, well, if the blue y equals 3x, the red y equals x minus 2. So I'm going to write x minus 2. Basically, I set both of these expressions equal to each other because they both equaled y. So after I substituted in the 3x for this y, and I substituted in x minus 2 for this y, now all I have to do is solve this equation and find out what x equals. So my first move is to minus x from both sides. So when I do that, this cancels and I get 3x minus 1x is 2x. Next, I'm going to divide both sides by 2, and I end up with x equals -1. Okay, very important. Don't stop. Don't stop. Don't stop. So we know that x equals -1. which matches our other answer on the graphing when we graph. But once you find x, you have to go back and take that and find y. Here's what you do. Take the -1 and put it into one of the original equations. So I'm going to put it right here. So I took one of my original equations. It doesn't matter which one you pick. I picked the top one, and I wrote y equals 3x, and instead of using x, I substituted in the -1. So what is 3 multiplied to -1? It's -3, so y equals -3, and I write it right here. Now look, they match. So we were able to solve this system of equations by using the substitution method and not the graphing method. We got the same answer. When you state your answers, please make sure you do it as an ordered pair. We have another example where y is by itself, and in the second equation, y is by itself also. So, going to set it up the same way. Y equals itself. Okay, just like 4 equals 4 or 5 equals 5, x equals x, y equals y. So what I'll do, I'll say this is the red y and I'll say this is the blue y, and I'm going to take this x plus 3 and I'm going to substitute it in for the first y. So I'm going to say x plus 3 will represent my first y. Then I'll go back and I'll say, well, my second y, this blue one, that will be represented by 2x plus 5. What I did was I substituted this value in for y because they're equal. So now that I have my two sides set up, all I need to do is solve for x. Because I have two x's on this side and one on this side, I am going to get rid of the single x. So I'm going to minus x from both sides. What I end up with is 3 equals 1x plus 5. Well, my next move is to get rid of that 5. So what I want to do is minus 5 from both sides. When I do that, I end up with 3 minus 5 is -2, and that equals 1x. So that equals my x. So I remember that I need to say this as an ordered pair. So I'm going to write -2, comma. Now I'm going to take this -2 and I'm going to substitute it in to x. Probably right here, but it would work if I do it here also. I did choose the top equation, so I did y equals x plus 3. I wrote it here, and I'm going to take this -2 and place it where x is. Substitute it in. So here's my -2, so I'm going to put -2 where x is, and then I'm going to do plus 3 equals y. So let's solve that. 3 plus -2 is 1, so y equals 1. There's my answer. X is -2, y is 1. Should I check it? I can check it with my other equation. Watch. -2. Let's put it right there. And what is 2 multiplied to -2? That equals -4. And what is -4 plus a positive 5? That should equal 1. And it does. And that's my y value. So it works perfectly. Alright, on this slide, or this example, we have y by itself here, but y is not by itself here. So you have a choice. I'm going to show you how to do this two ways. The first way is you could take this 4x and move it over and then get y by itself so that they're both isolated. And here's what it looks like. So if you look, our first equation is y equals x plus 1, and now the second equation that used to look like this, now it looks like this, y equals 6 minus 4x. So you could solve it the way I did in the first example. So, and for time reasons, I'm not going to show you that again. But I do want to show you another way to solve this equation, and here's how this will look. If you were in my classroom right now, what I would do is I would say y equals x plus 1, and then I would ask the class, I'd say, what does y equal? And you would say x plus 1. Then I'd do it again. I'd say, what does y equal? And you'd say x plus 1. And I'd say, what? X plus 1. Okay, so you would say y equals x plus 1. And the reason I do that is look at this equation. It's 4x plus y, but I don't want you to say y. I want you to say x plus 1. Because we're going to substitute in x plus 1 in the spot where y used to be in this equation. And here's what it looks like. I'm going to take x plus 1, and notice instead of y, I wrote x plus 1 in its spot. Now I'm going to solve this because all I have is one variable. Whenever you solve a system of equation, you want to isolate and get just one variable, and then you can solve it. Because with two variables, it's very difficult to solve. So I combine my 4x and my 1x, and I get 5x. 5x plus 1 equals 6. So we'll solve this super quick. And 6 minus 1 is 5. So 5x equals 5. And divide both sides by 5. We get x equals 1. Remember, all of our answers are ordered pairs because it means this is where the two lines touch on the graph. So once you find x, you have to go back and plug it in. So take the 1 and go to one of the original equations. I'm going to use this one. I'm going to take the 1 and put it where the x is. So I'll put it right here, and 1 plus 1 is 2. So y equals 2. My answer is x is 1, y is 2. That's where our lines will meet. In this equation, both of them have the variables on the left, and none of them have a variable isolated. So what you want to do is get one variable by itself. And if I look, I could move the 2y over here, or I can move the minus y over here to get x by itself. So that's what I'm going to do. I'm going to add y right here to get x by itself. So this second equation is x equals 5 plus y. Again, if you're in class, I'll say, what does x equal? And you'll say 5 plus y. What does x equal? 5 plus y. Next, I take the top equation, which is x plus 2y equals negative 1, and I write it here. But notice, I did not write the x because instead of using the x, I am going to substitute in this new expression, 5 plus y, because that really represents x. So I'm going to write 5 plus y right here. So let's solve this. Much easier now. Y plus 2y is 3y. So 5 plus 3y equals negative 1. Okay, so I showed my work and I solved, and I ended up with y equals negative 2. Be careful. On our last couple of examples, we found out what x equaled. On this example, we found out what y equals, so I have to make sure I write the negative 2 in the y spot. And just like before, pick one of the equations. I'm going to pick the second equation, x minus y equals 5. And what I'm going to do is substitute that negative 2 in for y. So it's going to look like this. X minus negative 2, because that's y's value, equals 5. So if we simplify that, x plus 2 equals 5. I think we can do this in our head. The answer is 3. So x equals 3. And my ordered pair is 3, negative 2. And that's my answer for this question. Real quick, I just included this so you had steps to follow to help you remember how to solve these. I'm not going to talk about them and waste time, but they're here for your notes. Alright, we have one more example where the variables are all on the left and we do not have one isolated. If I look, I see this y does not have a coefficient, or it has a coefficient of 1. So I'm going to use this top equation and get y by itself. So I'm going to move this plus 6x and I'm going to minus it to the other side. In red is what it looks like now. So y equals 11 minus 6x. So now I know what y equals, so I'm going to take my second equation and substitute in this red value here for y. Here's what that will look like. Notice that this red value is in the same spot where y was. So 2 multiplied to y is going to be 2 multiplied to this parentheses. So now it's important to use the parentheses because we're going to have to do the distributive property here. We're going to have to distribute the 2 to the 11 and to the minus 6x. And I'm going to show you what the work looks like right now. After I distribute, I get this. And now it's time to combine like terms. So I'm going to take my 3x and put it with my negative 12x. Well, now I have a two-step equation, and we know how to solve two-step equations. So for time reasons, I'm not going to walk you through this. I'm just going to show you my work and show you how I got my answer for x. Well, here's what I got. I ended up with x equals 3, so it's right here. Alright, so now that I know that x equals 3, I need to take that value and put it back into one of these equations. I'm going to pick the first equation, but it doesn't matter, so I'm going to take the 3 and put it right there. Okay, so next we'll just solve this. This is 18, and I have y plus 18 equals 11, so then I minus 18 from both sides, and I end up with negative 7. So y equals negative 7. And remember, our entire answer is 3 comma negative 7 because it represents a point on the graph where they both meet, where both lines touch. Okay, we're going to end with a word problem. Jenna is deciding between two different cell phone plans. Well, the first plan has $50 sign-up fee and then costs $20 per month. But the second plan has a $30 sign-up fee and costs $25 per month. So after how many months will the total cost be the same? We have to start by writing our equations. So let's write our equations first. Plan 1 will be in red. It's $20 per month, so 20x, but plus $50 just to sign up. The second plan will be $25 per month and then $30 just to sign up. So now let's set these two equal to each other. And the reason we can do that is because y is isolated on both of them. So just like in our first example, y equals itself. So y equals y. Okay, so we substituted these values in for y. And now we're going to just solve this. So minus 20x from both sides. I ended up with x equals 4. And remember, once we have that, we're not done. We have to go back and find out what y equals. So we're going to plug 4 in to one of our equations. How about this one right here? So what is 20 times 4 is 80, and then we're going to do 80 plus this 50. So 80 plus 50. We end up with 130. You could have taken the 4 and put it here. 4 times 25 is 100. 100 plus 30 is 130. So it says, what will the cost be? Well, remember that x represents our months and y represents our cost. So our cost will be $130. That's our cost. Let's answer the last question. If Jenna has to sign up for a 1-year contract, so that means 12 months, which plan would be cheaper? Okay, so I did a visual. The blue plan, it starts off lower but is a steeper slope, and the red plan starts off high but is a flatter slope. And at 4 months, they both equal 130. But after that, the red plan is cheaper. So I would say plan 1, because after they meet, which is only 4 months, and you want 12 months for a year, after they meet, the red plan will be a lower price. We have a few slides for practice problems. So here's one of them. Here's some more practice problems. Okay, more practice problems here. And lastly, you do have a word question I want you to try. So bring any questions you have to class. Next time we meet, make sure you write down your questions as you go. Take care.